Magandang araw mga kasipnayan! Welcome to Sir Ocnic's YouTube channel. In this video, we will illustrate permutation of n objects and we will find permutation of n objects taken r at a time. But first, let us have a review on factorial notation. Simplify 8 factorial, 3 factorial. 8 factorial, 3 factorial is just the same as 8 factorial times 3 factorial. 8 factorial is equal to 40,320, while 3 factorial is equal to 6. Therefore, that means that 40,320 times 6, which is equal to 241,920. If you're going to use calculator, you key in 8, shift, x raised to negative 1 times 3, shift, x raised to negative 1, and then the equal sign. You will also get 241,920. Simplify 14 factorial all over 12 factorial to factorial. In this case, let us expand first our numerator. That is equal to 14 times 13 times 12 factorial. We will stop at 12 factorial simply because there is a 12 factorial in our denominator. Since we have common factors between the denominator and then the numerator, we may cancel out 12 factorial. 14 times 13 is equal to 182 all over 2 factorial, which is equal to 2. 182 divided by 2, that is equal to 91. If you're going to use calculator, you key in 14, shift, x raised to negative 1 divided by, open parenthesis, 12, shift, x raised to negative 1 times 2, shift, x raised to negative 1, close parenthesis, and then the equal sign. You will also get 91 as a result. Let us now discuss permutation of n objects taken r at a time. Permutation is defined as an arrangement of objects in which order is important. Each arrangement can be made using all or some elements of the set of objects without repetition. Let us illustrate first permutation. Suppose that you want to visit the homes of 3 friends, namely Alex, represented by A, Betty, represented by B, and Chandra, represented by C, but haven't decided in what order. What choices do you have? Your first choice would be you go to Alex's house, then to Betty's house, and then to Chandra's house. But you may also have Alex's house, Chandra's house, and Betty's house. Suppose that you are going to visit first Betty's house. You have the options Betty's house, Alex's house, and Chandra's house. Or Betty's house, Chandra's house, and then go to Alex's house. But you may also visit Chandra's house first. So you have the options Chandra's house, Alex's house, and Betty's house. Or also Chandra's house, Betty's house, and Alex's house. So all in all, you have 6 possible ways in visiting your friends' houses. The permutation of n objects taken r at a time is denoted by P, open parenthesis, n, comma, r, close parenthesis, or NPR, which is equal to n factorial all over the quantity n minus r factorial, wherein r is greater than or equal to 0 but less than or equal to n. Take note that if r is equal to n, then NPR is equal to n factorial. Let us go back to our first problem. Since you want to visit the homes of 3 friends, namely Alex, Betty, and Chandra, but haven't decided in what order, what choices do you have? This one may be represented by P of 3, which means the permutation of 3 taken 3 at a time. We have 3 options and you're going to visit these 3 options. So that is permutation of 3 taken 3 at a time. Using the formula n factorial all over n minus r factorial, we will arrive at 3 factorial all over 3 minus 3 factorial, which is equal to 3 factorial all over 0 factorial. Take note that the value of 0 factorial is equal to 1 and not 0. So this one is the same as 6 all over 1, which is equal to 6. As shown earlier, you have 6 options in visiting the different houses of your 3 friends. P of 8, 5 is read as permutation of 8 taken 5 at a time. That is equal to 8 factorial all over 8 minus 5 factorial, which is equal to 8 factorial all over 3 factorial. 8 factorial is equal to 40,320, while 3 factorial is equal to 6. That is 40,320 divided by 6, which is equal to 6,720. P of 12, 2. That is equal to permutation of 12 taken 2 at a time, which is equal to 12 factorial all over 12 minus 2 factorial. That is equal to 12 factorial all over 10 factorial. By expanding the numerator, that is the same as 12 times 11 times 10 factorial all over 10 factorial. We may stop at 10 factorial simply because there is 10 factorial in our denominator. We may now cancel out the common factor between the numerator and the denominator, which is 10 factorial. What will remain is 12 times 11 all over 1, or simply 132. That means that the permutation of 12 taken 2 at a time is equal to 132. Permutation of 14 taken 3 at a time. That is equal to 14 factorial all over 14 minus 3 factorial, or simply 14 factorial all over 11 factorial. Expanding the numerator, we will have 14 times 13 times 12 times 11 factorial all over 11 factorial. Canceling the common factor between the numerator and the denominator, which is 11 factorial, we will have 14 times 13 times 12, which is equal to 2,184. That means that the permutation of 14 taken 3 at a time is equal to 2,184. P of 10, comma 2. That is permutation of 10 taken 2 at a time, which is equal to 10 factorial all over 10 minus 2 factorial. Or simply, 10 factorial over 8 factorial. Expanding the numerator, we will arrive at 10 times 9 times 8 factorial all over 8 factorial. Cancelling the common factor between the numerator and then the denominator, which is 8 factorial, we will have 10 times 9, which is equal to 90. Permutation of 12 taken 3 at a time divided by 5 factorial. Let us solve first the permutation of 12 taken 3 at a time. That is equal to 12 factorial all over 12 minus 3 factorial. Or simply, 12 factorial over 9 factorial. Expanding the numerator, that is equal to 12 times 11 times 10 times 9 factorial over 9 factorial. Cancelling the common factors, that is equal to 12 times 11 times 10, which is equal to 1,320. That is the value of permutation of 12 taken 3 at a time. Let us now divide the result by 5 factorial. 5 factorial is equal to 120. 1,320 divided by 120 is equal to 11. Permutation of 15 taken 3 at a time divided by 3 factorial. Let us first solve for permutation of 15 taken 3 at a time. That is equal to 15 factorial all over 15 minus 3 factorial, which is equal to 15 factorial all over 12 factorial. Expanding the numerator, we will have 15 times 14 times 13 times 12 factorial all over 12 factorial. Cancelling the common factor between the numerator and the denominator, which is 12 factorial, we will have 15 times 14 times 13, which is equal to 2,730. That is now the value of permutation of 15 taken 3 at a time. Let us now divide the result by 3 factorial, which is equivalent to 6. 2,730 divided by 6 is equal to 455. 9p2 all over 4 factorial. Solving first for the value of 9p2, that is equal to 9 factorial all over 9 minus 2 factorial, which is equal to 9 factorial over 7 factorial. Expanding the numerator, we will have 9 times 8 times 7 factorial all over 7 factorial. Cancelling the common factor, which is 7 factorial, we will have 9 times 8, which is equal to 72. Let us now divide the result by 4 factorial. 4 factorial is equal to 24. Therefore, that is 72 divided by 24, which is equal to 3. 12p2 divided by 4p2. Solving for 12p2, that is equal to 12 factorial all over 12 minus 2 factorial, which is equal to 12 factorial all over 10 factorial. Expanding the numerator, that is equal to 12 times 11 times 10 factorial all over 10 factorial. Cancelling the common factors between the numerator and the denominator, which is 10 factorial, we will have 12 times 11, which is equal to 132. Let us now solve for 4p2. 4p2 is equal to 4 factorial all over 4 minus 2 factorial. That is equal to 4 factorial all over 2 factorial, which is the same as 4 times 3 times 2 factorial all over 2 factorial. Canceling the common factor, which is 2 factorial, we will have 4 times 3, and that is equal to 12. Dividing the value of 12p2 by 4p2, that is equal to 132 divided by 12, which is equal to 11. Let us now summarize what we have discussed in this video. Permutation is an arrangement of objects in which order is important. Each arrangement can be made using all or some elements of the set of objects without repetition. The permutation of n objects taken r at a time is denoted by p of n comma r or npr, which is equal to n factorial all over n minus r factorial, wherein r is greater than or equal to 0 but less than or equal to n. If r is equal to n, then npr is equal to n factorial. Let us now check your knowledge. Try to solve the following items on your own. Do not forget to pause the video while answering the activity. P of 17, r is equal to permutation of 17 taken 3 at a time, which is equal to 17 factorial all over quantity 17 minus 3 factorial, or simply 17 factorial all over 14 factorial. Expanding the numerator, that is equal to 17 times 16 times 15 times 14 factorial all over 14 factorial. Canceling the common factor, which is 14 factorial, we will have 17 times 16 times 15, or simply 4080. Ten P4 over 4 factorial. Let us solve first for the value of permutation of 10 taken 4 at a time. That is 10 factorial all over 10 minus 4 factorial, or simply 10 factorial over 6 factorial. Expanding the numerator, we will arrive at 10 times 9 times 8 times 7 times 6 factorial all over 6 factorial. Canceling the common factor, which is 6 factorial, we will have 10 times 9 times 8 times 7, or simply 5040. Let us now divide the result by 4 factorial. 4 factorial is equal to 24. 5040 divided by 24 is equal to 210. Eight P3 divided by 4 P2. Let us first simplify the numerator. Permutation of 8 taken 3 at a time is equal to 8 factorial all over quantity 8 minus 3 factorial, or simply 8 factorial over 5 factorial. Expanding the numerator, we will have 8 times 7 times 6 times 5 factorial all over 5 factorial. Canceling the common factor, which is 5 factorial, we will have 8 times 7 times 6, or simply 336. Let us simplify the denominator. Permutation of 4 taken 2 at a time is equal to 4 factorial all over 4 minus 2 factorial, or simply 4 factorial all over 2 factorial. Expanding the numerator, we will have 4 times 3 times 2 factorial all over 2 factorial. Cancelling the common factor, which is 2 factorial, we will have 4 times 3, which is equal to 12. Dividing the numerator by the denominator, that is equal to 336 all over 12, or simply 28. Thank you for watching Sir Ocnic's YouTube channel. If you think that this video is a big help, hit like, feel free to share, and do not forget to subscribe. Always have fun in learning math. Enjoy learning! Thank you, and God bless.